Hello, we are going to be moving into neutralization reactions between acids and bases. So in a neutralization reaction, an Arrhenius acid reacts with an Arrhenius base to produce water and a salt. Please understand that when we're talking about, I'm using the word salt here, it's not just talking about table salt, sodium chloride, but it's a salt where you have an ionic substance composed of, a positive with a negative ion that will dissolve into an electrolyte. So this first thing is your general formula that you guys have to know, or general equation. Acid and base, like I just said, are going to make water and a salt. Now, most of us think of a neutralization reaction producing a neutral solution, which if we have a strong acid and a strong base, it will. But keep in mind that when we have different strengths of acids and bases, that different combinations will influence the pH of the salt. So you don't actually have to always have neutral at the end of a neutralization reaction. That's something that we would get more into with honors in AP. So for example, if we have hydrochloric acid, so this is my acid. I can also tell based on table K, but also the hydrogen out in front there is a pretty good clue. And then I have sodium hydroxide. That hydroxide was with a metal, so that's most likely my base. You can also find it on table L. That's going to make water. And water I'm going to write here as HOH for a minute, but you will also see it as H2O. Okay, now the hydrogen from the acid is going to form water with the hydroxide from the base. And this will be a liquid. Now the salt is formed from the remaining ions. You have your sodium ion, Na, and then you have your chloride ion, Cl, from the acid. Now you always want to keep the positive ion written first, followed by the negative one. So I'm going to place those together here to get, they're all +1, -1, so I just need one of each. So this will be NaCl, and that would be aqueous. So what does it actually look like in solution is really more like, and I'm going to leave out all the aqueous, just for time, but you would have all these ions floating around in solution. When they undergo the reaction, you would still have your water molecules. Those would not be separate. And then you'd have your sodium chloride. So if you look, the sodium and the chloride ions are present at the beginning and at the end. Those are considered spectator ions. So they're kind of like the spectators. They're watching what's happening. They're watching the reaction, but they're not actually participating in it. So that leads us with our net ionic equation. So if we take out all the spectator ions, we end up with H plus from the acid, my hydroxide from the base to make water. So you could either see this as H plus OH minus, and these would both be aqueous here, is going to yield water as a liquid. You may also see H plus written as hydronium, H3O plus, and then the hydroxide from the base. And this will still make water, but because of the extra atoms here, we'll make 2 moles of water. Okay, so you also need to know, besides the general formula, or the general equation, I should say, up here. Okay, you also need to know the net ionic equation for a neutralization reaction. Okay, so when acidic and basic solutions are mixed, we saw that the H plus, the hydrogen ion from the acid, and the hydroxide from the base form water. Those remaining positive and negative ions are going to form the salt. So we're going to do a couple. If you look through these, you're going to see they're all 1-to-1. So we're kind of simplifying them there because it's really what you're going to end up seeing for the most part. I'll give you a couple of practice ones where that's not the case. So here we have hydrochloric acid. Here's my acid. Potassium hydroxide, this is my base. Okay, I'm always going to go ahead and form water first. So I'm going to take my hydrogen from the acid and form water with the OH, and you can either write that as H2O, it's water, or if it's helpful to see it in terms of a double replacement reaction, you can write that as HOH. Okay, the remaining ions then are going to form my salts. So over here, I'm just going to label each of them. So I have K plus 1, and that charge I would get right off the periodic table. And then the chlorine or chloride ion is going to be Cl -1. That's the top charge for it on the periodic table. Keeping the positive one first, I see that I have a +1, -1. They cancel each other out. So that would give me the salt formula of KCl. Okay. If I keep going here, again, I'm going to have my acid and my base. Okay, I'm going to take the hydrogen, H plus from the acid, the hydroxide from the base to form water. Okay, the remaining ions that are left over is Na +1 and Br minus 1, which again I would get both of those off of the periodic table. It's plus 1 minus 1, they cancel each other out, so I just need one of each. So NaCl. Okay, and some of you guys will be noticing this is just simply a double replacement reaction. That hydrogen from, like, say, the second reaction is taking the place of sodium. Sodium is then going to take the place of hydrogen. So you can also think about it like that. So if you want to see it that way, you have hydrogen and lithium. Those are both of your positive ions. Hydrogen is coming in, it's going to kick out lithium, and then lithium is going to go back. So this is just, again, a variation of a double replacement reaction. I would have, you might write it as HOH, which is fine. Again, you can see it either way. And then you would have lithium, Li plus 1, and then the acetate ion C2H3O2, which on table E is negative 1. Okay, they're 1 and 1, they cancel each other out. So you'd have LiC2H3O2. Okay, as your examples. You could also see the reverse of this, so they could actually give you the salt and you would have to kind of work backwards and kind of break it apart in two and then come up with what the original acid or base was.